The French Saint-Chamond tank was a combat vehicle nearly 29.5 feet long and weighing 25.4 tons, equipped with the most powerful gun among tanks of the First World War period. It could reach speeds of up to 7.5 miles per hour, while its counterparts moved at a speed of 3.7 miles per hour. Despite the stated specifications, operating the tank was fraught with difficulties and crew casualties. The reasons for this lie in the circumstances surrounding the machine's creation, stemming from disagreements within the French military leadership. The history of the project began not on the front lines, but in administrative offices, where a conflict arose that influenced subsequent events. Late December 1915. Trench warfare was being waged in Europe. The situation at the front remained static. Engineering barriers and artillery fire made offensive operations extremely difficult. During this period, Artillery Colonel Jean-Baptiste Estienne held a meeting with engineer Eugène Brillier from the Schneider Company. Both parties concluded there was a need to create an armored vehicle to breach defenses. The idea was supported by General Pétain, and the Commander-in-Chief of the French Army, General Joffre, approved the project. Thus began the development of the first French tank, the Schneider. This event provoked a negative reaction from General Moret, the director of the Army Motor Service. All motorized ground transport fell under his jurisdiction. The approval of the project, initiated by an artillery officer and a civil engineer directly through Joffre, was perceived as bypassing the relevant department and interfering with the Motor Service's authority. For the head of the department, this meant a loss of influence. Moret did not openly criticize Estienne's project, given the latter's support from high command. Instead, delays in the development of the Schneider were engineered through demands for modifications and additional tests. Moret also decided to create his own tank model. Second Lieutenant Charles Fouché, a specialist in tracked vehicles, was called in to carry out the task. Moret asked if it was possible to design a vehicle capable of crossing a trench 4.9 feet wide, as the Schneider's crossing ability was limited to 3.3 feet. Fouché reported that the work could be completed in 4 weeks. However, the Schneider trials were scheduled for February 21, 1916, and the order was received on February 2nd. Thus, the deadline was not 4 weeks, but 19 days. Fouché was given a small workshop with existing equipment, 10 employees, and 2 American-made Baby Holt tractor chassis that had been purchased earlier. Due to the lack of time, developing a vehicle from scratch was not feasible. The decision was made to modify the Holt chassis by lengthening the track base and suspension. It was assumed that this would improve cross-country ability and allow the vehicle to cross wide trenches. Intensive work lay ahead within a tight time frame. Fouché's team worked around the clock. The staff slept 3 to 4 hours a day at their workstations. Drafting and welding were carried out at an accelerated pace. The success of the project was crucial for General Moret's reputation. On February 21st, the appointed day, a prototype named Apparatus No. 1 Type A was brought out to the test range. The design consisted of an elongated chassis covered with steel sheets to demonstrate its driving performance. The vehicle crossed a trench 5.7 feet wide, exceeding the requirements set by Moret. The Schneider also underwent its testing phase. On February 25th, the Army leadership placed an order for 400 tanks of this type. Despite the apparent conclusion of the competition, Moret continued work on his project. He instructed engineer Fouché to refine the design. Changes were made to the front section to prevent barbed wire from getting stuck in the suspension. To improve cross-country performance, the nose of the vehicle was lengthened and given a pointed shape. On March 17th, the third prototype crosses a trench 8.2 feet wide, surpassing the Schneider tank in this metric. Soon after, Murray approaches the management of the Forges et Aciéries de la Marine et d'Aumecourt Company, and in April 1916 receives an order from the Artillery Directorate for the production of 400 Saint-Chamond tanks. A conflict of interest arises here. The contractor is the same firm at whose facilities the production of Schneider tanks was planned. With the start of manufacturing Murray's equipment, the production of Estienne's machines is suspended. The order was approved without a finished Saint-Chamond prototype, without conducting a full cycle of trials, and without notifying Commander-in-Chief Joffre. Administrative leverage was employed to secure the contract. The order for 400 machines was based on a design for an elongated chassis with armor, while the final specifications of the tank, the composition of the armament, and the actual combat effectiveness had not been determined at that time. The development process took on the characteristics of an administrative rivalry. The designers were tasked with creating a combat vehicle based on the elongated chassis. Lieutenant Colonel Émile Rimail, the technical director of the Saint-Chamond Company, and one of the developers of the 2.95-inch field gun Model 1897, joined the work. His technical decisions defined the appearance of the future tank and had a significant influence on the outcome of the project. Previously, Rimailho had developed the 2.95-inch TR Saint-Chamond gun commissioned by General Manuel Mondragon. The gun had a barrel length of 28.5 calibers and used a shell weighing about 17.6 pounds with a firing range of up to 6,562 yards. Rimailho decided to install this gun on the new tank, insisting on its central location in the nose section of the hull. Such a layout differed from the solutions applied in the British Mark tanks, which had side sponsons, and Schneider tanks, which had the gun in the right part of the hull. Theoretically, this concept had advantages. The central position of the gun allowed for firing along the course of movement without the need to turn the vehicle or use limited side firing angles. The 2.95-inch caliber ensured superiority in firepower over 2.24-inch guns, allowing fortifications to be engaged from a distance. However, the practical implementation of the project encountered structural difficulties. The large caliber gun and its mounting required the use of an enlarged hull. The dimensions of the design tank were length 28.97 feet, width 8.76 feet, height 7.71 feet. The mass of the machine reached 25.4 tons, which was almost double the figures of the Schneider tank. At the same time, the length of the undercarriage remained unchanged as it was originally designed for a lighter chassis. This led to a significant disproportion. The massive hull was situated on a relatively short track base. The engineering solution applied in the Saint-Chamond was characterized by a substantial overhang of the hull beyond the tracks. Nevertheless, Rimailho and Murray continued work on the project. To compensate for the increased mass, an electric transmission was introduced. A 4-cylinder gasoline engine with a power of 6,7 seal drove an electric generator that powered 2 electric motors, each of which was responsible for the movement of the corresponding track. This system ensured a smooth ride and simplified the control process. Instead of a mechanical gearbox and clutch, the driver used current regulation to the motors. Furthermore, the electric transmission facilitated maneuvering, allowing the tank to turn by changing the rotation speed of the tracks. On a level surface, the Saint-Chamond developed a speed of up to 7 mil to good, which was a high figure for that time. For comparison, the speed of the Schneider tank was 5 miles per hour, and the British Mark up to 37 the good. The secondary armament included Cittore e 32 Hotchkiss machine guns of the 1914 pattern, placed in the front, rear, and side sections. This arrangement provided a circular field of fire and minimized dead zones, unlike the armament scheme of the Schneider tank. The crew of 8 men was accommodated in the hull, the internal volume of which exceeded the figures of other vehicles. The armor thickness was 43 duima in the front, 33 duima on the sides and rear, and 22 duima on the roof and bottom. These characteristics corresponded to the protection level of other tanks of that period and were intended to protect against machine gun fire and shrapnel. On September 1, 1916, the first Saint-Chamond unit was presented. Inspection of the vehicle by military engineers revealed skepticism regarding the design. The 12,6 duima wide tracks were subjected to the pressure of a 25,4 ton mass. Ground clearance was low. The design was based on the Holt tractor base. The center of gravity was shifted forward due to the location of the heavy gun in the nose. There was a risk that the vehicle would dig its front part into the ground during climbs or obstacles. Since production had already been launched and an order for 400 units processed, the process was not stopped. Work began on eliminating the defects. The tracks were widened from 12,8 duima to 16,2 duima, then to 19,7 duima. Additional rollers were installed at the front and rear to improve trench crossing capability. The running gear was reinforced due to high loads. The first 150 tanks were produced with a flat roof, on which enemy grenades would get stuck, creating a threat for the infantry following the tank. Subsequently, a pitched roof was introduced to roll grenades off to the sides. The observation cupola was removed, which limited visibility. General Estienne, appointed commander of the assault artillery, criticized this decision and demanded the return of the cupola for the driver mechanic. Due to the enemy's use of armor-piercing bullets, insufficient armor resistance was revealed. Additional 0.31-inch plates were installed, increasing the frontal armor thickness to 0.77 inches. This led to an increase in weight, a decrease in mobility, and a rise in the number of mechanical breakdowns. The last 100 vehicles were equipped with a 2.95-inch cannon of the 1897 pattern, with a barrel length of 34.5 calibers and a firing range of 6.8 miles. In combat conditions, the firing distance was a few hundred yards, which negated the gun's characteristics. By March 1917, a year after the order, the Army had received 48 finished tanks. Production was delayed due to modifications and a shortage of components. The last unit was produced in March 1918. The Army's need for machinery remained high. The first crews were formed and the vehicles were prepared. May 5, 1917, the La Faux salient. 11 tanks moved to positions in front of the enemy line. The crews performed a communications check and ammunition preparation. This was the first combat use of this model. After artillery preparation, the tanks began moving. The terrain was damaged by shelling. There were deep craters, destroyed trenches, remnants of barriers, and mounds of earth. Recent rains had washed out the soil. During the attack, the design features of the machinery became apparent. The first tank, when driving onto the edge of a crater, dipped its nose down and got stuck in the ground. The engine was running, the tracks were turning, but the vehicle remained in place. The track width was insufficient for the tank's mass on soft ground, and the forward shifted center of gravity exacerbated the situation. The second tank, attempting to bypass the stuck vehicle, drove onto a destroyed trench. The front part dropped down, the rear rose up, and the tracks lost traction with the surface. The 2.95-inch cannon dug into the bottom of the trench. The third tank performed a maneuver to provide assistance, resulting in it throwing a track. The mechanic attempts a repair under fire, but the running gear cannot handle the stress. German machine gunners take advantage of the situation. The French tanks grind to a halt, one after another, becoming stationary targets. Armor-piercing bullets punch through the armor, ricocheting inside the hulls. One of the tanks takes a hit through a vision slit. Shrapnel wounds the driver. Another catches fire after a hit to the fuel tank. The electric transmission proves vulnerable in combat conditions. A spark from damaged wiring causes the entire vehicle to go up in flames. The crew bails out through the hatches under machine gun fire. One Saint-Chamond out of 11 manages to break through the German defense line. The commander found a patch of solid ground and navigated the vehicle between the shell craters. The tank keeps moving, but it is only a local success. Without support deep within enemy positions, holding the territory is impossible. The infantry cannot keep up with the machine, and the other tanks are left behind in the mud. By evening, French forces return to their starting positions. The attack fails to achieve its objectives. On May 6th, the situation remains unchanged. Out of 11 tanks, only 2 remain combat ready. The rest are stuck, damaged, or have broken down due to technical reasons. 3 vehicles are destroyed by enemy fire, while the other crews face mechanical problems. Tankers are under fire, trying to recover the vehicles. Mechanics work in the mud amidst exploding shells, repairing tracks, patching holes, and replacing damaged road wheels. Command receives reports from the front indicating the failure of the project. The tank crews insist on necessary changes: wider tracks, a reinforced suspension, additional vision slits, and thicker armor. However, the main problem, the significant disproportion between the hull length and the track base, as well as the displaced center of gravity, cannot be fixed without a complete redesign. This would mean admitting the mistake of ordering 400 units, the unviability of the machine put into production by General Moray, and the influence of subjective factors on decision-making. By November 1917, the Saint-Chamond groups are not combat ready. The reason lies in a shortage of spare parts. Electric motors and generators fail, and tracks wear out in a short time. The industry struggles with producing components for the electric transmission. The tanks sit in depots, immobilized due to design flaws. The company proposes a technical solution. In June 1917, engineers present a modernization project, increasing ground clearance to 22 inches, modifying the front hull, and redesigning the layout. Essentially, they are proposing the creation of a new tank on the existing chassis. However, it is too late. The Renault FT light tank is being prepared for release. It is compact, maneuverable, and less expensive to produce. It possesses cross-country capability unavailable to the Saint-Chamond. The proposal is rejected, and modernization is not carried out. The Army forms 12 groups of Saint-Chamond, but they do not demonstrate high efficiency. The result of deploying this equipment on the battlefield remains unpredictable. A significant number of the machines get stuck or break down before even reaching the front line. The crews were critical of their machines, yet they carried out their assigned tasks. The personnel took their places in the vehicles, dreading the difficulties associated with crossing uneven terrain and trenches. Comparisons were drawn with the conditions of the Renault FT crews, who, despite their cramped single-man turrets, faced immobilization in mud less frequently. 48 Saint-Chamond units were converted into supply vehicles by removing their guns. The resulting transporters were used to deliver ammunition and rations to forward units. Nevertheless, their operational characteristics remained the same. Mobility issues and technical malfunctions persisted. But there was no weaponry for return fire. The only advantage was the increased useful volume due to the absence of the gun and ammunition load. The conditions of trench warfare, for which the Saint-Chamond was designed, revealed a mismatch in its characteristics. Rugged terrain, narrow passages, and ground with low load-bearing capacity hindered the operation of the vehicle with its elongated hull and narrow tracks. The design, developed for crossing wide trenches on proving grounds with firm soil, proved ineffective in actual frontline conditions. The advantage in crossing ditches over the Schneider tanks, planned by the designer Murray, was not realized in practice. In the summer of 1918, the situation changed. After halting the German offensive, Allied troops launched a counterattack, leading to a shift from positional warfare to mobile warfare. The front line shifted, and combat operations moved to open spaces with relatively undamaged landscapes. Under these conditions, the effectiveness of the Saint-Chamond increased. On flat and firm terrain, the tank's design flaws, such as the tendency to get stuck in trenches and craters, became less significant. The tracks provided movement over dry ground, and the electric transmission facilitated maneuvering. A speed of 7.5 miles per hour gave it an advantage over infantry and horse-drawn transport. The presence of a 2.95-inch gun allowed the Saint-Chamond to be used as an assault artillery asset. The French command revised its application tactics. Instead of operating in the vanguard to breach fortifications, the tanks began to be used as mobile support artillery. The vehicles followed the advancing troops, suppressing firing points and machine gun nests from a distance exceeding the effective range of small arms fire. The enemy faced a change in the nature of the threat. The tanks took up positions at a distance of about 550 yards, turned, and fired at targets with 17.6-pound shells. 4 machine guns provided all-round fire coverage, protecting the vehicle from enemy infantry. The armor withstood rifle fire, and the density of German anti-tank artillery in these sectors was low. Operating conditions for the crews improved. The need for evacuation and field repair of stuck equipment decreased. The Saint-Chamond demonstrated the ability to maneuver and deliver fire. The vehicle's role changed. From a breakthrough asset where it showed low effectiveness, it transformed into a fire support weapon. The tasks of direct breakthrough were performed by the light Renault FTs, which possessed better cross-country ability and a rotating turret, while the Saint-Chamonds followed in the second echelon, suppressing enemy resistance. Heavy tanks shifted from fortification assault tactics to suppressing resistance with fire from a distance. In the period from August to early October, Saint-Chamond tanks were deployed in a series of effective operations. Casualty statistics dropped. Vehicles returned from combat missions undamaged, and the number of mechanical breakdowns decreased thanks to operation on suitable terrain. The crew's attitude toward the machines changed for the better, and morale improved. The effectiveness of the 25.4 short-ton machines was reconsidered. In early October 1918, in the Montfaucon area, the 1st American Division encountered resistance from German forces during an offensive. The French command sent a group of Saint-Chamonds to support the Allies. The tanks took up positions and opened fire on the fortifications. 2.95-inch shells struck trenches, machine gun nests were destroyed, and German infantry retreated. American units launched an attack supported by French armor and secured positions with minimal losses. This was the last battle involving the Saint-Chamond in the First World War. On November 11th, the armistice was signed and hostilities ceased. The 4-year conflict ended, bringing significant human casualties and geopolitical changes to Europe. French tank crews abandoned their vehicles. For the Saint-Chamond, the war ended just as it had found its tactical niche. A few months of relatively successful use did not outweigh a year and a half of technical and tactical failures. The arrival of the Renault FT diminished the relevance of heavy tanks. The light machine was cheaper, easier to produce and operate, while fulfilling most tasks. The comparison between the technically complex Saint-Chamond with its electric transmission and the maneuverable Renault FT was not in the former's favor. The decision to decommission the vehicles was made quickly. All surviving Saint-Chamonds were withdrawn from service immediately after the armistice. The machines were neither preserved nor offered for export. 400 tanks, produced at General Murray's initiative, were sent for scrapping. The hulls were melted down, electric motors removed for spare parts, and guns returned to artillery depots. By the early 1920s, the fleet of these machines had practically ceased to exist. One surviving example remains at the Tank Museum in Saumur. It is displayed next to the Schneider, the competing model that influenced the history of the Saint-Chamond's creation. The two tanks stand together as a testament to the competition between design bureaus of that period. General Murray had realized his plans. 400 tanks of his design entered production, exceeding the order volumes for the Schneider. His administrative ambitions were satisfied and his position in the military hierarchy restored. However, the price of this result included casualties among tank crews, financial costs, and the failure of a number of operations. Interdepartmental competition had impacted the state of the Army. Colonel Estienne, conversely, became one of the key figures in the creation of the French tank forces. His concept formed the basis of the Renault FT, a machine that defined the industry's development for decades. The bet on maneuverable and reliable technology proved correct, unlike Murray's heavy tank concept. The history of the Saint-Chamond demonstrates the risks of administrative conflicts influencing military technical development. Equipment designed amidst interdepartmental strife may prove ineffective, despite its armament and armor specifications. Viewers interested in material regarding the impact of command decisions on the course of combat operations may appreciate this video. You are invited to suggest examples of military equipment for future reviews in the comments.